Welcome back. Okay, so exceptions are neat. Exceptions are predefined in Java, but exceptions are objects, so we can define new exceptions of our own. We can extend runtime exception for an unchecked, or we can extend exception for a checked exception. This allows us to define new types that are specific to our problem domain to help give better diagnostic information. We can include reporting, we can include putting things out to error logs, we can include recovery information if it's an interactive application. So exceptions are exceptionally important. So how do we define one? Let's make an exception for a search that fails inside of our address book. So we can make a no matching details exception, and usually exception names are very verbose and very explicit about what it is you're looking for. So no matching details exception is going to extend the exception object. Okay, so we get all of the things that an exception knows about, and we're going to just specify the things that are important for this exception to be able to report back out to the calling object. So it's a class. Let's set up a field. We'll make that field the key. And when we create a no matching details exception, the no matching details exception will be created with the string value that was passed in, so that this exception will have a copy of the key that caused the error. We will also have a getKey method, an accessor, so that if the calling program wants to query the exception and learn what key threw the error, we could give that back. And then we will also override the objects to string method so that this error message will appear in the system.error log, will be available to be read over and parsed for by text processing programs to discover where the errors occurred in this latest run. So defining exceptions is just like making a class specifically to report back mistakes. Report back data about what caused the mistake or the problem. Now, exceptions are not the only tool at our disposal for defensive programming, but they are the tool that should be left in the code for production code. But on the development side, we have this other tool called assertions. And if the name or the word assert is drawing some memories, it probably is taking you back to chapter 9 with unit testing, because JUnit uses asserts extensively. Assertions are for developers, not for runtime. And assertions are best for checking internal consistency. So let's take an example. We have different types of assertions. One is where we just assert a statement. It will come back true or false. Or we will assert a statement about some other statement. So assert some comparison with an expression after it. So the Boolean expression is where we're stating something that should be true. And if the assertion fails, then it will throw an assertion error. So remember, errors are also throwable, and they're different than exceptions. So how does this get used in practice? In our developer test code, and you may opt to not use assertions in your code, you may just opt to have JUnit tests. So this is kind of like a choice that you get to make on how you're going to be testing objects through development. But let's assume we're using the assert statement. At this point, we are going to put some assertions into our remove details method to ensure that the state of the object is proper once we're done doing our task. So assert statements usually occur at the bottom and make a bunch of claims about the internal state of the object once the code that's actually doing the work has done its job. So we're going to pass a string in to this method, and the job of this method is to remove that object from the internal structure of the address book. So if the key is null, throw an exception. Okay, we can't do that, so we're still going to have our throw from before. Then ask the key object to be passed into key in use. If the key is in use, then we want to do the work of actually removing the object and reducing the number of entries. And if the key is not in use, we just skip over the work to be done because there's nothing to be done. Once we get through that, pass key in use to key. Let me rephrase that. Pass key to key in use. And after we've done this, the key should no longer be in use, so this should be false. So we want to say, if this is false, we want to say that it's not the key in use. We want to assert that the key is not there. And if we've tried to remove the object and the key is still there, something went horribly wrong. So this should come back as true unless there was an error above it. And then consistent size is going to be the method which is going to return true or false. And if consistent size returns false, then we want to put as our assertion the book size in remove details is now inconsistent. These are ways to handle things in development, but these statements should never be in your production code. These are strictly for testing. It's not a choice of throwing exceptions or using assertions. Okay, it's not an alternative. You only use them for internal checks of the state of your object. So for instance, don't actually do the removal and then say that's the assertion. That's not the way these things are meant to be used. Okay, they're just additional checks on the state of the object once the code in the method has run. So once a mutator mutates, let's make sure we haven't accidentally put the program in a state, or this object in a state that's going to cause problems. So you can kind of see how assertions are related to exceptions. It's part of error handling, but it's really a different animal. Okay, when we come back, let's look at how we might write code to recover from a recoverable error. See you in the next lecture.